Solder pad scalability is one of the main features of Modelithics microwave global models for surface mount capacitors, inductors, and resistors. Since these models scale with respect to solder pads, designers can quickly and accurately determine performance over a range of PCB solder pad stack conditions. Modelithics models contain two parameters that control how the model handles PCB solder pads in both the simulation and the layout. These parameters are called sim mode and pad mode. Let's first look at the sim mode parameter. This parameter controls how the model functions with respect to device parasitics, substrate effects, and solder pad effects. The default sim mode setting is sim mode 0, which is the setting for a full parasitic model. With this setting, the model includes the solder pads. The pads are drawn in the layout based on the pad width, pad length, and pad gap parameters. Pad gap simply refers to the amount of space between solder pads. When a model is set to sim mode 0, the reference planes when simulating are located at the edges of the solder pads. This means that when you simulate a model with sim mode 0, the response is actually the combined response of the part itself plus the solder pads. When sim mode is set to 1, the model simply functions as an ideal model. Device parasitics, substrate effects, and solder pad effects are all removed from the model. Again, the reference planes when simulating are located at the edges of the solder pads. Sim mode 2 removes pad-related parasitics from the model calculation and solder pads from the layout. This setting allows users to specify their own pad geometry. Sim mode 2 should be used if the pads have already been modeled in an EM simulation of the layout. With sim mode 2, the reference planes when simulating are located at the edges of the component body. By default, the generated layout contains the component body outline without the pads. Sim mode 3 is similar to sim mode 2, with the only difference being substrate and ground interactions are also removed from the model. Internal device parasitics are the only parasitics still included. The pad mode setting allows users to specify whether or not the pads are drawn in the layout. This feature is used to override the default pad layout operation of the sim mode parameter when needed. Be aware that the pad mode setting has no effect on the model simulation. When pad mode is set to 0, the model defaults to the sim mode setting. This means that the pads are included or removed from the layout based on the sim mode setting. Setting pad mode to 1 enables the pads to always be placed in the layout. This setting overrides sim modes 2 and 3. When pad mode is set to 2, the pads are removed from the layout. This setting overrides sim modes 0 and 1. Again, the pad mode setting only determines whether or not the pads are drawn in the layout. It has no effect on the model simulation. Now, we'll discuss how to use the sim mode and pad mode parameters together to perform EM circuit co-simulations. Let's say we want to perform an EM circuit co-simulation of this circuit here, which simply consists of a Modelithics model for the passive plus 0402N surface mount chip capacitor family. 50 ohm microstrip lines are located on both sides of the capacitor. We want to perform an EM analysis of the microstrip lines while performing a circuit analysis of the capacitor model. We also want to perform the EM circuit co-simulation with the model set to sim mode 0. Here's the layout generated for the EM circuit co-simulation with sim mode and pad mode of the model both set to 0. You can see the 50 ohm microstrip lines along with the solder pads for the capacitor. Again, the idea here is to perform an EM analysis of the layout while performing a circuit analysis of the capacitor model. However, there is a problem because the solder pads are not only included here in the layout, but also in the model when set to sim mode 0. That means that the solder pads will mistakenly be counted twice when we perform an EM circuit co-simulation. We can correct this by generating the layout for the EM circuit co-simulation with the model's sim mode parameter still set to 0, but now we'll set the pad mode to 2. Now the solder pads are no longer included in the layout. We can now perform a correct EM circuit co-simulation with the model set to sim mode 0. Now let's say that we want to perform an EM analysis of the solder pads rather than simulating them within the model. Shown here is a different representation of the same circuit we just looked at. In this case, the model's sim mode parameter is set to 2 because we want to remove the solder pads from the model. Note that the pad mode setting must be set to 0 or 2 so that the pads are not included in the layout. We want to do this because we've already created our own solder pads here in the schematic. This will allow the solder pads to be included in the EM analysis. Here's the layout generated for the EM circuit co-simulation. You can see the reference planes are located where the edges of the component will be. Now, using this layout, we can perform an EM circuit co-simulation. Remember to set the model's sim mode parameter to 2. Well, we hope you enjoyed this short video. Please contact us if you need any assistance.